We're going to check out our study guide for our angles and angle relationships today. So first one I have here, determine the measure of angle x. I need to remember triangle. It has a total angle measure of 180 degrees. So if I can add these, they should equal 180. Now I have an equation to solve. Combine my like terms. Remove the constant by performing the inverse operation. Then I have x is 48. So I've got 48 degrees. Okay. Second one here, same triangle, so the same measurements and everything. List the side lengths from shortest to longest. Now my shortest side length is going to be my shortest or my lowest degree measure, so here. So the side length that's the shortest is B. Next in order, 62. Across from that is A. Lastly, C. So shortest to longest, BAC. Number 3 here, determine the measure of the third angle. So I've got, again, the two that I know, plus the one I don't, equals 180. Combine like terms. Subtract. I get 122 degrees. Okay, we're going to notice that number 4 follows the same pattern as number 2. I already calculated this. This one is longest to shortest. So I got to be really careful with the language here. Here's the longest one, E. And then my next longest, F. And then the shortest one at the end this time, D. All right. Next one, this is the exterior angle. The exterior angle, we remember, is equal to the sum of the alternate interior angles. So not the one next to it, but the ones across from it. So 36 plus x equals 118. Solve for x. I get 82. Angle B here is x. There's no other expression. So it's 82 degrees. Last one on this page. Now this one's a little bit tricky. The thing I need to remember here is vertical angles. This angle here is the same as this angle over here. So this is 48. Now I've got this triangle to look at. So I have 48 plus x equals 180. Now I have to remember my like terms. X plus x is 2x. Do my inverse operation to remove the constant. I get 2x is 132. Divide 2. I'm going to end up with x equals 66. And let's check our work. 6 times 2 is 12. Seems good. So each of these is 66 because they're both only x. So 66 degrees is for each angle measure there. All right, so we're noticing this is a lengthy study guide, but it's because we got these big images on each one. In this figure, line 1 is parallel to line 2. If measure of angle 8 is 49 degrees, determine the measures of the other 7 angles. So I've got 49 degrees here. And I can figure out the one next to it by subtracting that from 180, because remember, a line is 180 degrees. I think this one also gives me an important lesson in the fact that these aren't always drawn to scale, right? This looks obtuse, but it's 49. Okay, now the one across from it, 49 degrees, 131 degrees. Remember, these correspond to the ones down here, so these are all the same as the ones on the top. All right, same thing for the one on the bottom here. I have measure of angle 1 is 52 degrees. Find the other angle measures. So let's find the one next to it. So I get 128, and then I really have the same thing. Corresponding angles copy over here. 52, 128, 128, 52. And that happens because of the parallel lines and the strategies that we have studied. All right, let's check out our next one. I got this map here. We know that this is parallel to this. So it tells us right here. Which angle is alternate interior to angle 6? So angle 6, alternate interior, so inside 2736. Alternate to it would be angle 2. Which angle is corresponding to angle 5? Here's angle 5. Remember, corresponding same position, but on the other part of the parallel lines, so it's got to be 7. Which angle is the same side exterior to angle 1? So angle 1, here's angle 1, same side of the transversal and exterior, 1 and 4. So I'm looking at this one right here, angle 4. You got to look at those vocab words very carefully. Consider these triangles. How do you know the triangles are similar? Okay, so similar, they got to have the same angles. So I'm going to check this out. Triangle TSU has angles 90 degrees, 34 degrees, and this one we don't know. Okay, so I'm going to take 180 and subtract 90. And then I'm going to subtract 34. And I get 56. So that means I have 56 degrees here. Now my larger triangle, TRV, I can do the same thing. 180 minus the angles that I know, 90, 34. I'll get 56, the same thing. So all three angles are the same for both triangles. That means they're similar. So these triangles have the same angle measures, so they are similar. When we write a similarity statement, we use the triangle names. Triangle TSU is similar to triangle TRV. How can we use transformations? So can I slide, spin, reflect, or dilate? It's got to be dilate, smaller to larger or larger to smaller. So we can say we can enlarge triangle TSU to be the same size as triangle TRV. All right, this one in the figure, JK is parallel to MN. This is really important. These are parallel. So if I know that, I can kind of tilt it a little bit. Remember, draw this out. Here's my transversal. So why does that help me? This is 82. This has to be 82 also. This is alternate interior. I got another alternate interior over here with another transversal. This also has to be 67. This happens because, remember, parallel, parallel. That's what they tell us right here. All right. Last thing, remember these angles like that problem we had before. This is vertical angles. Okay, so now let's label this. Angle M, 67 degrees. KLJ, KLJ, this one, 31. Angle K, up here we had 82. We have the same figure. JK is parallel to MN. Write a similarity statement. So let's make sure that we copy what we had before. We had 82, 31. 31 is here, and we had 67. I want to make sure I go in order. LKJ. So L to K. So I'm going towards the 82 degree. So I want to start with L for here. L. I want to go towards the 82 first. N. And then this went to J, the 67. This goes to M, the 67. Last figure here. We got RU is parallel to VX. So RU is parallel to VX. So these lines are parallel. RX is parallel to TX. So RX, I don't see those connecting here. I think this is a mistake in how this is written. It should be RV is parallel to TX. So these are parallel. TY is perpendicular, 90 degrees. Okay, so this is perpendicular to RU. So that implies 90 degrees. Cool. TY is perpendicular to VX. Yeah, so that's going to happen. So these are all 90 degrees here. Question is TSU similar to YWV? So let's go TSU similar to YWV. All right, so they both have a 90-degree angle. What else do we know? I got this going through here. So this angle has to be the same as this. Okay, so really, once I got two angles the same, the third angle has to be the same. So we can say, yes, they are similar. They have the same angle measures. Is TSU similar to TWX? So TWX. Now I'm looking at this larger one. Okay, so they both have a 90-degree angle. Right? And they both share this angle at the top. This angle is the same for both the little triangle and the big triangle. So that means the third angle has to be the same. So again, we can say yes, they are similar. They have the same angle measures. Last one, TSU, again the small one, similar to YSR. So YSR. So let's check that out. They both have a 90-degree angle. Okay. And then if I look at another thing here, this angle is the same as this one, right? Because I got that transversal here straight up. So those are the same. So these two also have to be the same. So again, same reason. Yes, they are similar. They have the same angle measures. All right, so hopefully that helps you, and work hard. You're going to do fine.